Pressure and depth. In the previous chapter, you learned that an essential feature of a mask is that it has a nose pocket that can be pinched from the outside. You also learned that a mask with a reduced internal volume can be equalized more easily. These features are directly linked to an extremely important factor for divers. Pressure increases with depth. But what is pressure? In physical terms, pressure is a force exerted on a surface. Let's examine a practical example of pressure. A person walking on fresh snow will sink deep down into it, while someone wearing skis will sink much less. In the two cases, the total weight of the person remains the same, but what does vary is the surface area over which the weight is distributed. Skis increase the surface area, so each single unit of the surface area has to bear a lesser amount of the total weight. There are different units of measurement for pressure. Kilogram per square centimetre, which is equal to the force of 1 kilogram spread over a surface of 1 square centimetre, or PSI, pounds per square inch. Let's now take a look at our planet. All around the Earth there is a layer of air that goes from the Earth's surface up to a great height. This is our atmosphere. Molecules of air have weight. This means that the Earth's surface and all the objects on it bear the weight of all the molecules above. This force, generated by the weight of the air molecules, is known as atmospheric pressure. At sea level, the sum of the weight of all the air molecules above is equal to 1 atmosphere, just a little more than 1 kilogram per square centimetre, or 14.7 psia. As we go up a mountain, the column of air above us decreases, and therefore the pressure is less than 1 atmosphere. Now let's go underwater. Molecules of water are much heavier. A column of salt water about 10 meters, 33 feet high, weighs about the same as the entire column of atmospheric air. This means that for every 10 meters, 33 feet of depth, the weight of the salt water generates a pressure of 1 atmosphere. This pressure is known as hydrostatic pressure. As divers, we are interested in the total pressure we are being subjected to. Therefore, we use the term absolute pressure, which is the sum of the hydrostatic and atmospheric pressures. In this way, we take into account both the column of water above us, as well as the column of air exerting a force on the Earth's surface. So it's easy to see that on the surface we have a pressure of 1 atm. The final A means that we are referring to absolute pressure. While, as we descend beneath the surface, the pressure increases progressively. At 10 meters, 33 feet of salt water, the pressure is already 2 atm. At 20 meters, 66 feet, it is 3 atm, and so on. It is not easy to notice these variations in pressure because our bodies are made up of mostly solids and liquids, which are not compressible. However, if we take a closed plastic bottle full of air with us under the water, we can see that as we go deeper, the volume of the bottle decreases.